All right, guys, I had to cut that video short. But we're gonna start up again here, and we're moving on to the next question. And the next question is asking not for an area; it's asking for the length of DE. So this is where things get a little bit more complicated. Base times height seems pretty easy, but when we're trying to find a length of a side rather than the area, things get a little bit more complex. Especially since we don't have any angles that are shown in our parallelogram, right? We don't have any 45, 45, 90. We don't have any 30, 60, 90, so we can't really find sides by using that. Instead, we're going to set this up a little bit differently. I know that if I take the base times the height of this triangle, or I'm sorry, of the parallelogram, it's going to be equal to, well, the base times height. That seems pretty straightforward. Base times height should be equal to base times height, right? Now, does that really work if I use different bases and different heights? For example, what if I said 9.4 was my base? Versus what if I said 13 was my base? You would assume, and you'd be correct to say, it shouldn't matter which one your base is. Shouldn't matter. So, this is how we're actually going to set this up. If we're trying to find a side, or basically not a side, we're trying to find the altitude here, which is a height. I'll just label it x. DE is what we're trying to find. If that's what we're trying to find, then I'll put in x for one of the heights, but I got to figure out what base that one goes with. So which base would that be? Well, it's perpendicular to this one, and we said they have to be perpendicular, right? So this would be a base, this would be a height, those are perpendicular. So maybe I'll just do that one first. 9.4 times height. Or, I'm sorry, maybe I'll put x, because we labeled it x. 9.4 times x. I'm going to rewrite that. 9.4 times x. That's a base times a height. Okay. We have another base. Our other base is 13. If I were to tilt this over, it's going to be a little bit more than 90 degrees, but if I turn it over to its side where that 13 was on the bottom, we could call that a base. But what would my height be? Well, I do actually see a 90-degree angle marking. And remember when we talked about altitudes a long time ago, we said altitudes could be outside of triangles, and they also can be outside of parallelograms here. So my altitude is a little bit outside, but that's okay. It's still, if I turn it over, that's still 9 inches saying from the bottom to the top. That's how tall it is. So the 13 would be multiplied by the 9. Those are perpendicular. Then it's just a matter of solving for x. Let's see. 13 times 9, I got to find my calculator, because I'm going to have to divide that by 9.4. And I got 12.4 inches. That means that DE there is 12.4. So just a quick reminder here, the two things to remember. This base times height is different than this base times height. We just chose different bases and different heights, plugged in what they are. There should be there's two numbers that could be bases, and there's two numbers that could be heights for every parallelogram. 9.4 would be a base for right there or right here, and 13 would be a base on this one or this one. There's only two different ones you could pick. And we just set these things equal to each other. We figured out if this was the base, what would the height be? And we set those equal to each other. We were given 3 of them. We needed to find the 4th. And there it was. Maybe a good time to pause now if we have questions. Moving on to triangles. Area of a triangle formula. Does anybody know what it is? I can pause and say it if you know it. Area of a triangle formula. You got it? All right. I don't know if you guys said it or not, so I'm just going to go through it. Area of a triangle formula is... and maybe I should write it differently. Thinking about this here. Sometimes people write it like this. A with a little t. So that they know they're talking about a triangle. I don't know. And then we'll do equal to 1/2 base times height. So if you said that, good work. Or if you were just thinking it, good work. Area of a triangle is 1/2 base times height. We have a base. We have a height. Again, any side could be considered a base. But we just have to know that the height or the altitude has to be perpendicular to the base. And we've actually talked about this with triangles before. What is the area of the figure below? This is one of those times, the first ones that you guys are going to encounter, that you actually have to split up these shapes into different figures. So the rectangle would just be base times height, which is 12 times 5. 12 times 5 is 60, I do believe. And then we got to figure out this triangle as well. And on this one, they were pretty nice and they divided it for us. They won't always be like that, though. So if I'm doing this triangle now, basically what I have to think here is I know that this is 5 because this side should be the same as this opposite side. So basically this piece right here is 5. And then I got to think about its height, and I have to make sure it's perpendicular. Well, what I see here is that to the very tip of the triangle, that's just going to be 4, because I basically took 16 minus 12 to figure out what just this piece would be. Because it says the whole thing up there is 16, so if we cut that, that little piece would be 4. So if we know our area of our rectangle is 60, and the area of our triangle is base times height divided by 2, and maybe we can do that over here on the side with a little scratch work. Area of a triangle is 1/2. My base was 5 times height was 4. That would be 10. So 60 for my rectangle plus 10 for my triangle. That'll equal 70 total. I'm going to check my work here and make sure I didn't screw something up. Looks like I got it right. So I'll label it centimeters squared, and we'll move on. If you have questions, make sure you raise your hand so we can pause the video. Last one here. Now, you could look at this different ways. You could look at this picture and think, okay, I see, I'm just looking at the picture. I haven't even read the directions yet. But I'm looking at the picture and I could think, okay, I've got 4 triangles. So I could do the triangle formula 4 different times. But what I like to look at it as is this. And I'm going to see if I can make this a little bit easier. Let's go like this. And I'll choose a couple different colors. And I'm basically going to shade what I'm looking at. I'm going to call this one triangle. And I'll call this one, well, everything else, the other triangle. So I'm basically only doing 2 triangles here. 2 triangles is going to be easier than 4. It's going to be less work. And the reason I chose those as my triangles is because I see that they both have a base with an altitude that's perpendicular. And I know they're perpendicular because they got the little red angle markings. So this is going to be pretty easy. If I'm just taking the red triangle first, I believe that's red. I am colorblind. But if I take that top triangle, I'll say that. If I take the top triangle, I could even redraw it if I wanted to. Maybe I'll do that just to make it easier. X, Z, this is G, and this is Y. And then I can label those pieces, showing that that's perpendicular. XZ is 39, so this whole piece is 39. HW we don't have, and YG we do have is 21. So we have a height, we have a base, 39 times 21 times 1/2. 1/2 base times height. And I'm going to do that in a second. But for right now, I'm going to redraw the other one now. So that's the area of the top. The bottom, it doesn't have to be perfect, but X, Z, W, H. HW we said was 20. And XZ again is 39. So for this one, area will equal 1/2 my base times my height. And then it's time to calculate. The top is, 409.5, and the bottom was 390. So if I add those together, X, Y, Z, W equals 799.5 units squared. That is it. Look for triangles. Even if you're doing parallelogram stuff, look for those 30, 60, 90, 45, 45, 90, and sometimes you might even come across some that you're going to have to use sine, cosine, and tangent for to figure out those other sides. But that's it for this lesson. You guys can start the worksheet. Please work hard on that for the rest of the class period, and that is due tomorrow.